Hello, math learners! Our lesson for today is about the area of a sector. The learning objectives are: you are going to define sector of a circle and compute for the area of a sector given a central angle in degree or radian measure and the length of the radius. What is a sector of a circle? A sector of a circle is a region bounded by two radii and an arc of a circle. The shaded part is the sector. Let us look at the illustration. Given the center of the circle, you draw a circle and you choose 2 points on the circle. Now this portion, the shaded part, is what we call the sector. Let us have the first illustration. The area of a sector with a central angle of 90 degrees is 1/4 the area of the entire circle. So in this figure, you have the shaded part, which is equivalent to 90 degrees or 1/4 of the area of the entire circle. Recalling the formula for the area of the circle, that is equivalent to pi r squared, then we have the area of the shaded part, which is equal to 1/4 of the area of the circle. And this will mean 90 degrees over 360 degrees times the area of the circle. And reducing 90 degrees and 360 degrees, you will have 1/4. And let us represent the area of the circle as pi r squared. So the area of the shaded part is equivalent to 1/4 pi r squared. Let us have the second illustration. The area of a sector with a central angle of 45 degrees is 1/8 the area of the entire circle. Let us have this illustration. This shaded part is only 1/8 of the circle, which is equivalent to 45 degrees. So the area of the shaded part is equal to 1/8 of the area of the entire circle, which means 45 over 360 times the area of the circle. And this is equivalent to 1/8. If you will reduce 45 and 360, it is 1/8 times the formula for the area of the circle. So the area of the shaded part is just simply equivalent to 1/8 pi r squared. Let us have the area of a sector in degrees. The area of a sector is a fractional part of the area of the entire circle. Let us look at this illustration. Having the center of the circle, you draw the circle and choose 2 points on the circle, and it has shaded this part. By this time, we have to find the area of the sector. And then, let us locate also the central angle, which we are going to represent by C. So this part, that's the central angle. So this is the radius represented by R. And we have to take note again that the area of the circle is equivalent to pi r squared. The area of a sector is equal to the central angle over 360 degrees times the area of the entire circle. And let us represent the central angle as C. So we have area of the sector is equal to C over 360 times pi r squared, where A is the area of sector, C is the measure of the central angle, and R is the radius. Let us have an example. Find the area of a sector with a central angle of 60 degrees and the radius of 9 cm. So this is the illustration. The central angle is 60 degrees, the radius is 9 cm. The formula is area of a sector is equal to C over 360 degrees times pi r squared. So let us substitute 60 degrees to C and 9 cm to r. And then simplify. 9 squared is 81. The square of cm is cm squared. Then take the value of pi, which is equivalent to 3.141592,654. And then you can cancel the degree unit. And the result now is 42.41 cm squared. So the area of a sector is 42.41 cm squared. Take note, do not round off the value of pi. Use the whole value of pi from the calculator. And this is the approximate value of pi, equivalent to 3.141592,654. The formula for finding the area of a sector may be written as follows. Area of a sector is equal to the measure of the arc over 360 degrees times pi r squared. Since the measure of the central angle is equal to the measure of the corresponding arc. So in this illustration, the measure of the central angle HDG is equal to the measure of the minor arc HG. So to find the area of a sector, given the measure of the arc, we have area of a sector is equal to M over 360 degrees times pi r squared, where A is the area of the sector, M is the measure of the arc, and R is the radius. Let us have an example. The measure of the arc of a sector of a circle is 45 degrees. The length of the radius is 8 cm. Find the area of the sector. This is the illustration. Given the minor arc equivalent to 45 degrees and the radius is 8 cm. Using the formula, area of a sector is equal to M, which is the measure of the arc, over 360 degrees times pi r squared. Then we have to substitute 45 degrees to M and 8 to R. Then simplify. The square of 8 cm is 64 cm squared. And then the value of pi is 3.141592,654. And simplify. The result is 25.13 cm squared. All you have to do is to round off the final answer to 2 decimal places. Again, the approximate value of pi is 3.141592,654. Next, let us have the area of a sector in radians. The area of a sector of a circle can be measured also in radians. In the figure, the central angle AOB intercepts minor arc AB. If the arc intercepted by the central angle has the same length as the radius, then the measure of the central angle is equal to 1 radian. So it would be like this. If the measure from O to B, that's the radius, is 1, the arc is 1, so the central angle is also 1. And the unit now is radian. So let S be the length of the arc intercepted by the central angle theta, and R the radius of the circle. Now let us represent the central angle by the common Greek symbol, which is called theta, and R the radius of the circle. So given this illustration, we have theta and the arc represented by S and the radius by R. The radian measure of theta can be found by dividing the length S of the arc by the length R of the radius. So, theta is equal to S over R. This means that angle theta has a measure of S over R radians. And recalling the circumference of a circle that is equivalent to 2 pi r. Therefore, in a complete rotation of 360 degrees, S is equal to 2 pi r. Therefore, in this equation or formula, which is S over R, we are going to replace 360 degrees to theta, which is equal to 2 pi r, which is equivalent to S over R. And then cancel R. So, the equivalent measure of 360 is 2 pi, and the unit is radian. Hence, there are 2 pi radians in a complete rotation of 360 degrees. In 2 pi radian is equal to 360 degrees, we can divide both sides by 2. So cancel 2. What we have here is pi radian over 180 degrees. And divide pi radians by pi and also 180 by pi. Cancel pi. So what we have is 1 radian is equal to 180 over pi. Let us have an example. Given 45 degrees, we are going to convert this into radians. For the solutions, our conversion factor is pi over 180 degrees. So 45 degrees times pi over 180 degrees. What we have is 45 degrees times pi over 180 degrees. Cancel the degree unit and reduce 45 and 180. So we have 1/4 pi or 1 pi over 4. And simplify, we have pi over 4 radian. So meaning 45 degrees is just simply equivalent to pi over 4 radian. Then, given 60 degrees, we have to convert this into radian. So for the solutions, 60 times pi over 180 degrees, and this is now 60 degrees times pi over 180 degrees. So, cancel degree unit and reduce, it's 1/3. So we have 1 pi over 3, and simplify, it is only pi over 3. So 60 degrees is equivalent to pi over 3 radian. Next, let us express radian measure in degrees. So given pi over 2, for the solutions, we have to multiply pi over 2 with 180 degrees over pi. By this time, we can cancel pi. So, what we have is 180 degrees over 2, which is equivalent to 90 degrees. So, pi over 2 is just simply equivalent to 90 degrees. Next, given pi over 4. By the way, if you are given the radian measure, there is no need for you to write the word radian for the unit. It is understood that pi over 4 is already in radian measure. So to express pi over 4 into degrees, we have to multiply pi over 4 by 180 degrees over pi, so that you can cancel pi, and what is left is 180 degrees over 4. And dividing 180 by 4, the result is 45 degrees. Meaning pi over 4 is just simply equivalent to 45 degrees. In the figure, angle theta is subtended by a minor arc AB. And we have to take note again that 360 degrees is equal to 2 pi radians. And for the formula of the area of the sector, which is equivalent to C as the central angle over 360 degrees times pi r squared, we are going to change C into theta over 360 degrees times pi r squared. And then change 360 into 2 pi times pi r squared. And cancel pi, so what is left is theta over 2 times r squared. Now this can be simplified into 1/2 r squared theta. So the formula for the area of the sector of a circle with radius r is area of a sector is equal to 1/2 r squared theta, where A is equal to the area of the sector and theta is the measure of the central angle in radians and r is the radius. Let us have an example. Find the area of a sector of a circle of radius 8 cm if the central angle is 45 degrees. So this is the illustration. Given this central angle equivalent to 45 degrees and the radius is 8 cm, first we have to convert 45 degrees to radian measure. So 45 times pi over 180 degrees. Then that is 45 degrees times pi over 180 degrees. Cancel degree unit and reduce 45 and 180, that is equivalent to pi over 4. So 45 degrees is just simply equivalent to pi over 4. And finding the area of a sector using this formula, all you have to do is to substitute 8 to r and pi over 4 to theta. And simplify, the square of 8 cm is 64 cm squared, and multiplying 164 and pi, that will give you 64 pi. And 2 and 4 is 8. So what we have is 64 pi cm squared over 8. And 64 divided by 8 is 8. So the area of the sector of a circle is 8 pi cm squared. Take note, do not simplify the value of pi in finding the area of a sector of a circle since it is in radian form. So the area of the sector of a circle is with pi if it is in radian form. Next example. A circle has a radius of 10 cm. Find the area of a sector with central angle of 70 degrees and give the answer in terms of pi. So this is the illustration. The central angle is 70 degrees and radius is 10 cm. So first step, you have to convert 70 degrees to radian measure. So 70 times pi over 180 degrees, and 70 degrees times pi is 70 degrees pi over 180 degrees. And simplify, what we have is 7 pi over 18. So 70 degrees is just simply equivalent to 7 pi over 18. For step 2, we have to find the area of the sector. So the area of the sector is equivalent to 1/2 r squared theta. Substitute 10 to r and 7 pi over 18 to theta. So the square of 10 cm is 100 cm squared, and simplify, it's 1 times 100 times 7, it's 700, and 2 times 18 is 36. And reduce, what we have is 175 over 9 pi cm squared. The area of the sector is equal to 175 over 9 pi cm squared. Do you have questions? If there is none, let's recap. So the area of the circle and the sector. So the area of the entire circle is equivalent to pi r squared. If theta is measured in degrees, then the formula for the area of the sector is equal to theta over 360 degrees times pi r squared. And if theta is measured in radians, then area of the sector is equal to 1/2 r squared theta. Do you have questions? If there is none, see you next time. Bye!